It's not magic engineering. It's trade-offs, isn't it? You don't get things for free.
From EE Tech and All About Circuits, this is Moore's Lobby. I'm your host, Daniel Bogdanoff. Today in the lobby, we're joined by Thomas Keller, the Director of Platforms and Core Technology at u-blox, to talk 5G, IoT, and a lot more. Thomas has been in the cellular industry for a couple generations of tech and has spent time at Analog Devices and Research in Motion, or RIM, famous for the BlackBerry, where he was a principal engineer, and he has a shining career developing and architecting cellular modems. At u-blox, he's the technical lead for a number of satellite and cellular chipsets and modules. Thomas, thanks for coming on the podcast. I'm excited you're here.
Thank you very much. Thanks for having me.
I'm curious, how did you first get into the world of technology, and what gets you excited about tech today?
I guess I've always been interested in technology. So my family background is watchmakers. So there's generations of people fiddling with small mechanical devices. And I always liked playing with that. Although I never really saw it as technology, it was just normal. But I guess I got an uncle who was an engineer when I was little. And he was working for a sort of German aerospace company. And he always did cool things like, building boxes that go into aircraft and doing satellites and that sort of thing. And that's sort of, I guess, the thing that drove me towards doing engineering. That then coupled with just being relatively good at maths at school and a bit lazy, that was a fairly obvious direction to go in there.
I got to dig into the watchmaking a little bit.
Mm-hmm.
When you were a kid, was that just kind of a mundane, ordinary thing that your family did? Because they're so complex. And then was it just watches and clocks?
Well, it sort of comes as a package. So my father was quite interested. I mean, the sort of normal job is repairing watches and clocks and things. But he was really interested in restoring things. So people would come with a old iron clock built by some village blacksmith 200 years ago in a cardboard box, which their grandfather had taken out of a clock case and not got back together again. And so one of his favorite hobbies was putting those things back together and figuring out which bits were missing. So I always thought that was quite cool. So I quite like that sort of thing. Just a sort of puzzle solving and getting old things back together.
Absolutely.
But it did feel perfectly normal. It wasn't as exciting as planes or electronics.
Yeah. So then you went to school for engineering, I assume?
I studied electrical engineering in Karlsruhe University in the south of Germany. And at SE in Paris, it's an engineering school there, which was lovely. Spent a year there, and then spent my final year. I'm a master's in Southampton, and did a project on distributed antennas. As my specialization in France was microwaves and antenna technology.
I love antennas. I think just
Yes.
it feels like modern magic to me, the fact that they work.
It completely is. And looking at antenna systems in the cellular cell towers now is just fantastic. It's just so much technology and so much work and magic in all of this. It's brilliant. And then I did like it in the UK and did a PhD in Southampton on mobile comms, and that's where I got involved in cellular communications, really. So I was working on a project which is part of the European, it's called the Fourth Framework Project for those who may remember this sort of thing. So it was a big European research initiative sponsored by the EU, or European Community, it was called back then, looking at candidate technologies for 3G. And quite a lot of things were evaluated, and I was working on OFDM stream, which then did not win that 3G competition. CDMA was chosen, so UMTS is a CDMA-based system. But then LTE, of course, switched to OFDM.
So you got your PhD, and then what was your first job out of school?
My first job was at a startup company up here in Cambridge. So that's the thing that got me here. And I worked for a company called Ubinetics. And we were really, really early, a tiny startup company to start with, looking at building a tester for 3G base station. So that was a time when the third generation systems were being specified, and all of the infrastructure manufacturers would start building the base stations, and there were no devices to test them with. So we were building test equipment that pretended to be a mobile device, which then people could plug into their base stations to test those. And those, of course, there were all the big established players in the market, but they were all relatively slow to get their act together, and we got in there first, which was fantastic.
I spend a lot of my time in a big test and measurement environment, and for any size company, the ability to move fast is so important. It sounds like it was a good place to be.
It was a great time because it was just 3G. Nobody quite understood how it worked, and the specifications were brand new and still being written, so nobody quite understood really what it all means. And we were one of the few companies who was sort of sitting between the infrastructure manufacturers and the exchange data and information with them. It was really, really fascinating to just see what can go wrong if you give a lot of sets of engineers a stack of paper and say, build me this, and what the different interpretations were. So that was fascinating, and we spent a few very happy years there building test equipment. And then later we did technology development for getting this 3G IP on a chip. And we did FPGA platforms and big DSP platforms and all sorts of rather fun projects.
After the confusion of 3G, how do you think the spec development changed for 4G and 5G to help kind of address some of that?
I guess it's a combination of things. I think the process matured a little bit because 3G was the beginning of 3GPP, of course, because 2G before was ETSI driven and quite a European affair. And 3G being a global organization just was very different. And I think the 3GPP specifications are quite interesting. Sort of every 10 years or so, you've got a big bang, you've got a big new thing.
Yeah, something new.
99 or 2000 was 3G, and 10 years later was LTE, and 10 years later or so, you've got 5G NR as an incompatible new system that breaks compatibility. And then alongside, then you get lots and lots of little deltas, little enhancements, new modes, new stuff. So every 10 years, it feels like there's a reset and the specs are relatively minimal, readable, clean. And then lots of people spend a lot of time adding features to this baseline. And things get more and more complicated and more difficult to enter, I think. And LTE was much smoother. I mean, it was a big relief to, I think, go back from the big complications that 3G had accumulated in all of the packet channels that get bolted on were ultimately successful in the market. They worked well, HSDPA and HSUPA worked well. But the specifications got very, very complicated. And LTE managed to just clean up the mess a bit and start with a more integrated system. And then, of course, more features got added to LTE. But I think LTE was slicker. And I think that's because just companies were more used to working together in the standardization process. And the organization just worked better as well.
Yeah, so some growing pains there. But it seems like we're on a good track for 5G, and even the early 6G talks are very, very collaborative, more than I've seen for other wireless specs.
And it is an amazing thing that such things work. The interoperability between things. I guess an engineer, I'm surprised by and impressed by quite simple things. And I'm genuinely impressed that there's electricity coming out of the socket in the wall if you think about the machine that's behind it. In many ways, the cellular networks are much smaller machines than the grid. But there are so many more players that all have to build equipment that interoperates. It's hard to believe. It's a really, really big achievement to see all of this stuff interoperating so well. So yes, I think people just have seen the need to work together really quite closely and share quite a lot of information at 3GPP as well. And I spent a little bit of time at 3GPP and really enjoyed it. I thought it was a really nice set of people doing pretty important work.
But then you've been at u-blox for the last 10 years or so. What brought you there, and what keeps you there? Because 10 years is not a short time to be at a company.
No, but it's a really nice company to be in. It's very, very technology and engineering driven. And we've got there's a variety of sites. u-blox has grown through acquisition and capturing sets of people. And the office I'm in is in Cambridge in the UK. And we've got a lot of pre-u-blox history, all of the people in the industry here. So a lot of people already, and there's a lot of experience base here. And I really, really like the technology side of things. I really like the focus on basically quality and doing the niches we choose to do properly. So that's a really nice environment for an engineer to be in, I think.
You mentioned the niches. Can you talk a little bit about where you have found yourself really kind of getting geeky with it?
So there's a big picture of the company. So headline figures a company. It's a bit more than 25 years old. It's a ex-startup from a few PhD students at ETH in Zurich. So that's where our headquarters are in Switzerland. It's all very nice. And the starting point of the company was GPS. They started as a little GPS startup doing GPS modules. And I was successful with that and then started doing their own chips. And that worked out well. And so this is really the sort of core of the company where a lot of the stuff has happened. And since then, other things have been added, short-range communications, cellular communications. It's a good mix because things work very well together for our customers, and often integration between those components for a lot of our industrial customers. And we don't have any, well, we do have a lot of u-blox branded products, but they all look like a module that then gets integrated into other people's kit, of course. And then if you look at the use cases in our markets, often the short range, the cellular, and the location works together. And all three components are normally needed. So to get back to your question, I believe, I came into the company really because they were looking for experienced modem designers. And I used to work at an office for BlackBerry, and they had a little research and development office in the UK, here in Cambridge. And when BlackBerry stopped the modem technology development, and there was obviously a team of people who were looking for the next interesting challenge to do. And it so turned out that u-blox was in need of an experienced modem development team, and that sort of worked out very nicely. And it's been a really good switch for me. I think it's been, and most of us, maybe 10 people or so, came across, and I think pretty much everybody's still there, which I think shows you something that is a good place to be.
Absolutely. So I know that positioning, you mentioned GPSs earlier, positioning is a core technology of u-blox. Can you talk about global positioning, and are there 5G elements of that, or do you consider them to kind of be discrete technologies?
Well, there's a simple answer and there's quite a long answer. I think the simple answer is, as I see positioning, as I use the label, I was really thinking of the big GNSS systems with the big satellites. So the GPSs of this world and the Galileos and those. And they have, at the moment, not much to do with cellular communication systems. However, obviously there's strong positioning requirements built into cellular communication systems, largely driven by emergency responder requirements in the US. And so there's quite a strong location without GNSS systems, cell tower-based location requirements built into the cellular standards as well. And a lot of the requirements are very similar, I think. And on top of that, of course, now you've got a lot of new developments in technology for other location services that people are starting to think about as well, that are based on different technologies. So the picture's a bit complicated, but I think if you look at at least u-blox's tradition, it really, for positioning, read GNSS. That's really where it is now. Indoors is, of course, really interesting. And if you look at our website, we've got a few interesting things as well based on short-range radio technology. But that's really the sort of market we're in. And I think that's where a lot of our core strengths are, in just trying to find where things are and communicating where we found them.
Okay.
That's not the official line, but yeah.
u-blox, where are we?
Yes, approximately. Yes, and it's fascinating. I think it's a really, really interesting problem.
It is, and it's incredibly useful. And when I look at some of the things that 5G promised to do, it almost expands on that location and positioning capabilities in many ways.
Yeah.
I think 5G was lauded as this like end-all be-all sort of technology because it promised a lot of things. So maybe paint us the picture, and then kind of where are we today?
4G was meant to be the end-all be-all technology as well, and so I think every 10 years there's a new end of technology sort of thing, dropping out of 3GPP. But let's do one step back.
Yeah.
LTE, 4G, is a system that was designed to be operated in sensible frequency ranges. Something that's mobile.
Sub 6 gigahertz.
Sub 6 gigahertz. That was understood by the mobile network operators. They had spectrum, they bought spectrum, they could refarm spectrum from 3G, and all was well. And the data rates sort of went up a little bit. And, the high data rate LTE modems are not much slower than 5G modems, really, in practice. But the real thing that I think the industry hit was just cost per bit and capacity in the network. It's the LTE is relatively limited to the spectral chunks that can be used for a cell. So it's, somewhere between 20 and sort of 5 megahertz realistically. And they are in chunks and is not very flexible. And you've got to allocate, say, 20 megahertz of spectrum for your LTE network. And if you've got something that's a few hundred kilohertz or some little scraps of spectrum or something that just doesn't fit the raster, then you can't really use the spectrum very well for these services, which is a shame because it's worth a lot of money if you can use it. And on top of that, the sort of efficiency of the modulation and the handshaking between the network and the UE it's much more efficient than 3G was, but it was clear that improvements could be done. So if you think about it from a mobile network operator's point of view, you've got spectrum and you would very much like to sell more bits to more users with your resource you've got. And that I think is really the driving factor behind the whole thing. It's not, and we might get to this when we talk about IoT applications. I don't think that the 5G technology will necessarily give you a significantly better experience as a user. But the driving factor, at least in my mind, is it will give the operator more capacity.
Okay.
Now, that, as always, is nearly true because there are clearly modes in 5G that will allow you services that you can't do with LTE, like UILC, which we might touch on in a minute.
A quick heads up for you listening at home. In the next 10 minutes, we're going to use some acronyms that I felt like as I was editing this could use some explanation. So we're going to pop in some Mozart, have a brief aside about 5G acronyms and topics, and then hop right back into our interview. The first one that Thomas just mentioned is URLLC, which stands for Ultra Reliable Low Latency Communications. Basically, you can do creative things with the 5G frames and sub-carrier spacings to get 5G's latency up to maybe 10 times lower than LTE's latency.
So spectral efficiency, odd bandwidths, odd spectrum arrangements, and access to new spectrum, that's the other thing. Spectrum that's just under 6 gigs, or then the millimeter wave spectrum at 20 watts. There's just areas of spectrum that are not really addressable with LTE, and the idea really being that this is a step to make use of those resources. And it's quite challenging. I think it's a huge step in technology to go, even just for the radio technology, it's analog stuff, the antennas and devices. It's just a very, very different thing. So we can see it from a few different angles, but that, in my mind, is a sort of driving factor. Is make more, give me more capacity. That's the one thing, and that's really the sort of first step was to see, can we make a bigger data pipe, and that was the rollout of 5G. It's another little part of the story. In order to make the rollout relatively simple, there's a mode for 5G deployment, which is called non-standalone, where essentially your mobile communicates with a LTE. You're an LTE modem, but you've got an extra data pipe which can be enabled just for user data, which then uses a 5G channel. And that's how most of the networks are rolled out at the moment. So if in your phone it says 5G on top, that probably means you're an LTE network, but you could be allocated a 5G carrier just for user data. But all of the signaling, all of the control and the interaction between the network and your phone works over LTE.
Interesting.
It was a great way of making rollout possible, because it meant that operators could roll it out slowly. You could just support a 5G carrier in some cells and not in others. You could only deploy it in hotspots. And that's great. But now we're getting to the point, and maybe we get there, where this is actually quite limiting, because a lot of the funky new features you can't really deploy in a setup, because things like latencies are determined by the control channels and not by the data channel. And if you're running over LTE, you're not going to get really low latencies, for example. So it's going to be an interesting shift that operators have to do. And that shift will, in my mind, have a big impact on what happens to the legacy LTE things, because at the moment you can support LTE and 5G together in a network relatively easily, because they're actually, behind the curtain, they're linked. Actually, it's still LTE in a lot of networks. But once you move away from this will have an impact on the IT services, and this will have an impact on the legacy LTE things. So that's that. So the first step was called EMBB. Enhanced mobile broadband. That was a big story. It was just data rates, basically. Those are headlines. It's just give me lots of bits per second and more capacity, different bits of spectrum, more antennas for more MIMO, just support for more efficient bit pumping. And that was the first iteration. That's pretty much what's deployed now, and that's what you would see, I think. It is non-standalone deployment.
So some terms for you. EMBB is enhanced mobile broadband. Basically, more data for your phone and faster. And then MIMO, M-I-M-O, stands for multiple input, multiple output. Basically, you can have 2 or 10 or 100 transmitting and receiving antennas that use the same radio channel, and this gives you better signal gain, and you can then use the spectrum more efficiently. And then, since we're here, let's recap again. A 5G non-standalone network uses 4G LTE infrastructure, and because of that, there are some limitations. And then a 5G standalone network is more of a true 5G network that doesn't need that 4G LTE infrastructure.
The next big wave of specification stuff that came out was snappily called URLLC, ultra reliable and low latency communications, I think. And that one's really meant as obviously low latency, really driving, I think, towards replacing industrial Ethernet and stuff like that, and with a much higher level of reliability, but the cost you pay for that is less capacity, of course, because there's no magic in engineering. And that's a bolt on top of the existing NR standard.
Okay, so 5G NR stands for 5G New Radio, and that specifically refers to the new radio technology portion of the 5G spec, and it doesn't refer to the network architecture and virtualization side of 5G. So if you hear 5G NR, think radio technology.
But again, this is meant to be machines that are big and expensive and power hungry and not IoT at all. This is, in my mind, I'd see this as robots. I'd see if you've got an industrial robot and you get a bit bored with your cables breaking, then you could sort of see a URLLC set up to control the different segments of your robot.
Or you get increased flexibility in your factory because you can reconfigure more quickly and that sort of thing.
Yes.
It's not so much people trying to stream this podcast in its full definition glory while driving down the road in the middle of South Dakota. It's kind of a factory, or even they talked about like remote surgery as a possible use case, that sort of thing.
Yes, I see it as industrial automation, big picture. It's stuff that's safety critical. It's stuff that needs to be low latency. Yeah. Into that comes a little strand which is sort of private networks, which is something that's really not possible in LTE, but in 5G is theoretically possible, that you could have a piece of spectrum you can deploy if you run a factory-owned 5G network in. And then you got your private 5G network, all of the data stays inside your private 5G network, and you can essentially replace Wi-Fi type things with that.
But then it's a lot more secure, and you have a lot more control over like SLAs and performance metrics, that sort of thing.
Yes.
And then what about massive machine type communications, or MMTC?
That's the third step, really. That's a corner of this field of technologies that's meant to support the Internet of Things. And that's really the sort of market, we find ourselves in. That's our traditional customers. And this is the one area where 5G isn't really very finished yet, I think. So what at the moment covers these technologies is a pair of unlikely twins. One of them's LTE category M1. So it's cut down LTE standard 5 megahertz bandwidth or so, reasonable data rates, but not fantastic. And because you've got lower radio bandwidth, you can build lower power machines. Another one with even lower bandwidth and even lower data rates is called narrowband IoT. And those two standards have been picked up into the LTE story. And they have been labeled 5G because they're sort of integratable into 5G, but they're not really based on a 5G network at all. They are LTE technologies. And that's what's deployed at the moment, quite successfully, especially Cat M1 in North America and places where there's actually quite a big market. And those ones are the components that now cover this 5G MMTC field. It's a bit limiting because it's based on LTE, which means it's, to all intents and purposes, tied to the LTE core network. It's nearly true, but it's probably true enough. And it doesn't integrate very well with a real 5G new radio interface. So the 5G new radio interface can work around it. You can allocate bits of spectrum for these LPWA, they're called, low power wide area networks, so M1 and narrowband IoT. But you can't reuse the bandwidth for those things to also do 5G NR with. It's quite a static allocation. And within that bandwidth is not very efficient because they are small, cheap devices with single antennas with narrow bandwidth, so you can't find a good bit of your spectrum at any one time. It's quite limiting. But they work and they're low cost and they're deployed. I mean, there's more than 500 million of those devices deployed. So it's a big market and they need to be served. But that's where 5G isn't quite there yet, I think. Now, steps have been taken in that direction with release 17. We'll bore you with a few release numbers now.
So a release is more or less a 5G spec update. There's this broader vision for 5G that the 3GPP has, and 3GPP is the governing body for telecommunication standards. So to get to that end goal for 5G, they do it in steps or releases, and they each build on the prior one and add more capability. Release 17 was finalized in March of 2022, and Release 18 was just finalized in June of this year. And now that we have Release 18, people can start building things for that spec, but effectively we're still living in a Release 17 world.
Release 17 is one of the increments of the 3GPP specifications, and that's what's sort of current at the moment. And that introduced a new device class with its reduced capability device. It's called RedCap.
RedCap. Interesting. So reduced capacity RedCap. I see. Can you tell me more about that?
RedCap devices is really the idea of cutting down the requirements for a mobile or device that can operate on the 5G NR network and cutting down cost and power consumption of those things. And it's quite difficult because there's an assumption of the minimum capability of a device to work on the network with all the other devices, and that's really based on how the sort of basic network signaling works. So there's a minimum bandwidth you need to be able to support to be able to acquire the network and communicate with the network. So it's not really a problem of the user data, it's really a problem of control of the controller. And RedCap introduced in Release 17, these RedCap devices were introduced to the 5G specs, and they allow you to build a device that only has got a single receive antenna, a single transmit antenna, and that only has to support a 20 megahertz contiguous bit of spectrum at any one time. So that's simpler than the normal NR devices, and it's not very attractive from a network's point of view because, of course, if you only got a single receive antenna, your performance is going to be worse. And if you only got a single transmit antenna, you can't do uplink MIMO. So it's not good for capacity, but it's a way of cutting down cost and cutting down power consumption. There are now devices in the market, but in reality, they, I think, are probably based on normal 5G chipsets. So this first generation of RedCap devices are not cheap. They're much bigger and by necessity more expensive and more power consuming than the old LTE equivalents, Cat M1 and narrowband IoT. So it's not a like-for-like replacement in technology. And on top of that, it's first-generation devices which are not cost-optimized yet. So it's a difficult choice, I think, for customers to buy these things now, and you'd have to have quite specific requirements to settle for those rather than for the LTE equivalent at the moment.
So is it almost a stepping stone technology? Because if LTE devices can be run cheaper and purchased cheaper, what's the advantage of a RedCap device?
Well, the real advantage now is just longevity of the technology. That's the only real reason I could imagine. And that's a big if you're happy with a service that an LTE, a much, much cheaper and much, much lower power LTE device gives you, of course. So if you've got an application that only needs a few megabits a second, then there's not that much gained probably nothing gained from RedCap today. But the one thing that RedCap will be, because it's a 5G NR technology, it'll have longer life on the network side. It will be supported for much longer. And there's a little bit more work to address the cost on the 3GPP side as well, because Release 18 will introduces a lower complexity flavor of RedCap, enhanced RedCap. And that'll cut down cost and cut down power consumption a bit more. It's still going to be bigger than the LTE equivalents, but it's a step in the right direction.
It's interesting to me that 5G is going both in the direction of high bandwidth, wide bandwidth, high data rates, and then like wide RF bandwidth. And at the same time, also looking at this very low power, reduced bandwidth space. It's almost just this kind of funnel or umbrella getting wider and wider every release.
Yes, it's trying to cover more and more use cases.
And that's the thing I think that's different about 5G, where with LTE it was so much very consumer focused, like, okay, how do we do video? How do we do some just data over radio networks? And 5G is so much more looking at more specific use cases and situations where that expand beyond just a simple consumer handset. Where at u-blox do you find yourself most involved with 5G specifications and 5G implementation?
Well, if you're going for 5G in this LPWA, in this honorary 5G sense, then of course our Cat-M and narrowband IoT products are sort of labeled 5G, but by 3GPP. And that's obviously something we're working on, but there's genuinely 5G technology that is not supporting the old LTE thing, which is satellite technology, is one thing we're looking at. So the new non-terrestrial networking extension of 3GP, another huge step for 3GPP to start supporting satellites, is quite an interesting area at the moment, I think. And we are really, really interested in the standardization. So we've got delegates at 3GPP, but we are very much in listening and finding out things mode than shaping the standards, because I don't think we are really a player that's big enough to influence standardization. But we are following this very, very closely, because a lot of our customers need guidance and ask us what sort of products they should deploy in which products, which technologies they should deploy in their products in their different markets, and we have to have answers for that, and we have to have views on that. So we're interested.
Yeah.
And we're building what we think makes sense for our customers. It's a really interesting question at the moment. If somebody comes to you and says, so what should I do? Should I do 5G? Should I do LPWA? Should I do Cat1? It's an interesting time for that. We're sort of sitting between the waves at the moment.
Yeah, that's a hard question to answer these days.
And it really depends on your application, on your location, and it depends on how long you think your products will live. I think that's at the end of it. 5G for IoT, there's not a question why it would be a good thing for IoT. I think it's not optional. It's going to happen. It's inevitable. The question is, when will the MNOs turn off, sunset their LTE networks?
Yeah,
it's not even. It's not sort of in 5 years' time, but in different markets, this will happen at different times, and it's going to happen. And the cellular IoT systems will move to 5G just because they have to, and that really depends on how advanced your operators are in your location. And places like North America and the US, you'll have the process will start relatively soon.
Mm-hmm.
And I think in a few years' time, they'll start probably refarming spectrum and take LTE spectrum and roll out more 5G. And I'd expect that some of the most advanced operators in areas will start sunsetting LTE in the mid-2030s. So if you're selling products, if you're building and selling products with a long lifespan, then you will want to think about that. Obviously, in other parts of the world, LTE is going to live for much, much longer. Europe, for example, I think it's unlikely that LTE will not be supported for 20 years or so.
Sure.
So you've really got to think about it. So at the moment, I mean, what we see is interest in 5G really for these long life cycle, high cost products for automotive, agriculture, industrial. You think about utilities and smart grids and smart buildings, all of those things. I think it does start to become quite interesting now. And I think quite quickly we'll see second and third generations of the RedCap implementations as well, as the costs will come down. But for a lot of products in a lot of places, LTE is still a very, very viable solution. But it's a difficult conversation. It's a difficult decision-making process for customers. Do they really have to spend the money on 5G now if they don't need the data rates?
And you can't just wait a year until it's a little cheaper. Like technology marches on.
Well, technology does not. I mean, RedCap is becoming cheaper, and it's clear that more, just from a chipset side, more focused designs for lower cost chipsets will come on the market and are coming on the market. It will drive costs down. And with that will come easy decisions, I guess. But the power consumption is still a problem. I don't think you can build a device that's truly very small. The tracking devices, these the desert metering and things, it's just not yet the technology, I don't think. That's an easy winner there. And for this, we need changes in the specifications. Their release 18 will give us another step in the right direction, where we cut the bandwidth requirements down from 20 to 5 megahertz, I think. And another one of these steps, release 19, maybe we get to a point where it actually genuinely becomes technologically competitive with LTE.
Sure.
Now, LTE is these narrow bandwidth LTE flavors, of course.
What are some of the challenges of having IoT devices and low-power devices inside of a 5G spec?
I think it's really interesting, and I think I'm not the only one to see how long it actually takes to optimize a new standard. And that's both from a standardization point of view. The starting point for 5G was a really wide bandwidth, really high spectral efficiency data pipe. And it takes a long time to cut that down into something that's really optimized for IoT. And 3GPP will have their work cut out for another, 2 iterations, I guess, until we're really there. And until the standards are simplified enough, unless there is a way of accommodating low power devices on the network without sacrificing too much network capacity, it's unlikely we're going to see genuinely low power 5G, true 5G IoT devices. And that's that. But that's just physics. I don't think there's anything magic about this. It's just that it's a complicated thing. There's a lot of maths to be done. There's a lot of signal processing to be done. You need a wide radio, and all of these things are power hungry. But it will come. It just will take a little bit more time. And until then, and that's the thing, I think that's going to be the tension for the mobile network operators. They see more and more, and that they have to support more and more IoT devices using essentially 4G technology. And the tail will be very long, and they will have to support some service for these devices for a very long time.
That's a scary thing as a network provider.
It's definitely an uncomfortable thing, but it's probably inevitable, because there's a limited bandwidth at 3GPP. There's a limited bandwidth in the industry to throw a whole new family of technologies into the market at once. The 5G started as a solution to a capacity problem. So the first iteration really was targeted towards a bigger bit pipe, and that's not the same as a low power system.
Oh, definitely not. Yeah, those are very different use cases.
It's engineering.
Yeah. And that's, I guess, the interesting thing as I watch 5G and some early 6G conversations is we as engineers have to make these trade-offs of performance and capability and power, but at the same time, we want more of everything, and we want everything to be better.
Yes.
And there's no easy answer for that.
It's not magic engineering. It's trade-offs, isn't it? I mean, you don't get things for free.
Yes. So as you are listening in to the 3GPP conversations, what gets you excited about what's coming up next for 5G? And what roadblocks do you see that we need to work through as an engineering community?
I'm really excited to see the standalone mode becoming, being rolled out by networks and becoming more normal. I mean, at the moment, it's still a relatively small proportion of networks that actually operate standalone. So that's the thing we talked about earlier, the not utilizing the LTE network as a backend. Because while we're operating in non-standalone mode, a lot of the really new applications will be really difficult to support. The stuff where generally you need the low latency, where you generally need guaranteed network access. All of this stuff is hard to do, or maybe impossible to do with LTE components still attached. So I think standalone is great, and that will hopefully open the door to the new applications that have been promised, and that'd be good. And the other thing, I really do look forward to the evolution of the low, and I'm sort of hedging my bets here, aren't I? But I genuinely am looking forward to the low power applications and to the changes that need to be done to drive RedCap into a competitive corner. And if I had the magic wand, I would have hoped that they'd done that in the beginning, that there had been enough bandwidth to address the low power side of things pretty much from the beginning. But it was unrealistic, I think, for 3GPP to address both at the same time.
It sure would have been nice, though. But yeah.
Well, and the things that, if you step a little bit back from as a terrestrial thing, I think the whole satellite story is really exciting at the moment. There's this idea that satellite networks move away from proprietary standards to a to globally shared communal standard, and we'll have to see how that comes out. Of course, nobody quite knows yet where this is going to land, but it's definitely an attractive thought that you don't need to get a really expensive device to have a little bit of satellite fallback connectivity. Is a really good thought, because that could open up a genuinely new set of applications at a lower cost than what we got at the moment. That I think is really fascinating. And from an engineering point of view, I think low Earth orbit satellites are really rather entertainingly complicated to support by a mobile device.
Yeah. Well, there's even, handheld device, UEs right to satellites these days that's being explored.
Mm.
And that's a really interesting application to just skip the base stations altogether.
Yes. I mean, I'm not an expert in this field at all, but there's a lot of interesting challenges with these things. I mean, if you look at the sort of 5G NTN, so the non-terrestrial networking component of 3GPP, allows for store and forward operations with satellites. So you've got low Earth orbit satellites that essentially carry messages to users without being connected to the core network at the time. So you've got a low Earth orbit satellite that hasn't got connection to the core network for a long period of time while it's not over land. And it's completely non-trivial to figure out how this works with the 3GPP authentication protocols, for example. How can you handshake two ways?
Non-terrestrial networks would be a really interesting episode topic. We might have to dig into that at some point. But for today, we are out of time. So at the end of every episode, we like to do a lightning round, quick questions, quick answers. First question for you. If you had a magic wand and could change a law of physics, which law would it be?
Oh, law of physics, I'd definitely go for resistance. I'd have really high temperature superconductors.
Yes, that would be wonderful. Someday, maybe. I'm optimistic. Are you optimistic? What are your thoughts on room temperature semiconductors?
No, it is. There's surprising things being found, which is great.
It feels a little bit like the alchemy race of the 1600s. It's like, can we turn lead to gold? Can we turn silicon into a superconductor?
Yeah.
Looking back at when you started in the world of cellular and wireless, if you put yourself in those shoes and you somehow teleported into today, is there anything that would most surprise you about the state of wireless communications?
I think I am probably a prime example of an engineer who doesn't really see trends when they sort of happen. I remember me seeing, sort of photographs of being in Japan and just seeing people staring at their little mobile phones in the trains and watching television, watching films on mobile devices. And I just thought, what an incredible waste of bandwidth, and that'll never catch on. And if you see it from an engineering point of view, you just see all of these not even broadcast sort of servers, point-to-point video streams that I always thought were an appalling waste of resource and would never catch on. So I think I'd just be surprised by the cheapness of data, to be honest, by the ubiquity of connectivity and by how wonderfully seamless communication is today.
Yeah, I love that. No, I was in the kitchen yesterday and I told our home assistant, hey, turn off the TV. And it just happened. And I looked at my wife and said, 15 years ago, that would have been absolute magic. And
yes.
Today, I just did it without thinking.
Yes. Yeah. I mean, one gets used to things just incredibly quickly. And
so quickly.
The new normal is that machines just work.
Yeah, it makes me wonder about the future, but maybe that's another conversation. Thank you so much, Thomas, for being on the show today. This was great.
Thank you, Daniel. It's been a pleasure.
That was Thomas Keller, Director of Platforms and Core Technology at u-blox. I hope you enjoyed geeking out on cellular tech with me today. If you did, please share this podcast with a friend or coworker, and then come let me know on the Moore's Lobby and All About Circuits social media pages. Thank you for spending your time with Thomas and me today in the lobby. I'm your host, Daniel Bogdanoff, and I'll catch you next time.